Hi and Assalamualaikum. My name is FAKHRUDIN AZMI, and this video we will discuss about lab exercise 0.3, analyzing spatial data in ArcGIS software. Let's start.
Alright, to introduce into this lab exercise, firstly we will go through chapter 9, which is a spatial analysis. This chapter has to apply several GIS tools for several analyses such as a buffer, spatial joints, intersection of map layer, and cluster analysis. This chapter contains three main tutorials. In tutorial 9.1 is about buffering point for proximity analysis. This tutorial will teach you how to create a buffer, intersection buffer, and drag cell. In tutorial 9.2 is about conducting a site suitability analysis. This tutorial will teach you to identify which potential area and locate on map documents. This tutorial includes steps of define buffer car bit centroid, buffer bit car centroid, and intersect buffer. In tutorial 9.3 is about using multiple ring buffer for calibrating a gravity model. This tutorial will teach you how to analyze the intention of yaw data. This tutorial includes steps of create multiple ring buffer for open pool, spatial joint buffer, pool tag and yaw population, compute use rate, and create scatter plot of use rate versus average radius for each buffer ring.
In chapter 9, I will pick one tutorial, which is a tutorial 9.1, to show you how to make a buffer for school.
Right, from tutorial 1.9, I will show you how to make a buffer for school. Firstly, on the menu bar, click Windows and click Gestures. On the gestures, we type a buffer and click a buffer analysis. On the buffer analysis window, in input feature, we click a school. On the output feature class, we type a school buffer and save. On the linear unit, we type a 1000. We use a feed and then click OK. Wait for AZMI to finish processing and hide chest window. Right now move school buffer to top of the table of content and change the symbol of hollow. That's it, you have a school buffer.
Next, we will go through the chapter 13, which is a terrain mapping and analysis. In this chapter, we will learn how to analyze the terrain mapping and using dam and team. This chapter includes three main tasks, which is 1. Use a dam for terrain mapping, task 2. Drive slope, aspect and curvature from dam, and task 3. Build and display a team. In task 1 is about use dam for terrain mapping. In task 1, we teach you how to create a contour layer, a vertical profile, a shaded relief layer, and 3D perspective view from dam. In task 2 is about drive slope, aspect, and curvature from dam. In task 2, we'll teach you how to drive a slope layer, an aspect layer, and surface curvature layer from dam data. In task 3 is about build and display a team. In task 3, we'll teach you how to build a modify a team. You will use spatial analysis, 3D analysis, and art tools box to perform mapping and analysis in this section. Next, we will go to chapter 14, which is a viewshed and watershed analysis. This chapter will focus on create a viewshed and watershed on mapping and analysis it. This chapter includes 4 main tasks, which is a task 1, perform viewshed, task 2, create a new look shape for viewshed analysis, task 3 is delineate area-wide watershed, and task 4, drive upstream, contributing area at power points. In task 1 is about use perform viewshed analysis. This task 1 study about viewshed analysis and the effect of viewpoint height offset on the viewshed. In task 2 is about create a new look shapefile for viewshed analysis. This task 2 is study about create a cumulative viewshed by using 2 points, one of which is added through on screen digitizing. In task 3 is about Delineate area-wide watershed. This task 3 is a study about the step for driving area-wide watershed from dam. In task 4 is about drive upstream contributing area at 4 points. From using output from task 3, this task 4 study about how to drive point-based watershed. This task also show how then importance of snapping point of intersect to the stream channel. The last chapter that we will discuss, which is chapter 17, less coast path analysis and network analysis. In this chapter, we will learn terms such as location, allocation, network, path distance, shortest path analysis, source raster, traveling salesman problem, and term impedance. This chapter includes 6 tasks. Task 1 and Task 2 path analysis, we will work with the least accumulative cost distance in Task 1 and the path and the use of the network analysis attention. Task 3, run a shortest path analysis. Task 4, let's you build a geodatabase network datasets. Task 5, runs a closed set facilities analysis, and Task 6, runs allocation analysis. In Task 1 is about compute the least accumulative cost distance. In task 1, we will use the input from chapter 17 data to create the same output. In task 2 is about compute the path distance. This task is use the data from task 1 to compute the distance. The objective of this task is to find a least cost hiking path from the data in task 1. In task 3 is about run shortest path analysis. This objective of task 3 is to find the shortest route between two cities from data chapter 17. In task 4 is about build a geodatabase network dataset. From task 4, we will need to AZMI input datasets first, then put a personal geodatabase and the future datasets. This data we use in next task 5. In task 5 is about find closely facilities. In this task, we will use network dataset from task 4 and point shapefile with 2 fire stations in data chapter 17. In task 6 is about find service area. This task allows you to locate a suitable service area on map document. This service area considered with the distance and times from the coverage area. In my conclusion, what I learned from chapter 9, chapter 13, chapter 14, and chapter 17 in ArcGIS is about analyzing spatial data. During lab 3, I more explore to how to use tools that can analyze and measure geographic relationship. The result of the study helped me to use spatial data and plot in map document in terms of terrain mapping, viewshed and watershed. And last one is a least cost path and network. Last but not least, from what I study on lab 3, is more thing I need to explore, and I get interest to learn more about ArcGIS to apply in my study. Thank you.